And in cutting it short, I would like for everybody to review the latter part of the PowerPoints here. This is the slide regarding sampling methods. Um, the reason is that as I read your various dissertation proposals or research proposals, I saw that a lot of the various more complex sampling methods aren't so applicable to you as rather as methods for random assignment. We can of course go through this very quickly, but you also have the PowerPoints on Canvas, and I ask that you refer to those, please, and follow up on what we're going to talk about. But you know, the basic sampling method, as you can see here on the slide, is that we randomly select individuals out of a population. Now, a population is all of whatever there is. You need to remember that selection is much more difficult, and in some cases almost impossible, that is random selection, over random assignment. For example, I could select a convenience group. Let's say that we were doing research on both sections of this particular course, which I think comprises about maybe 20 people. So if we had all 20 people in a room, that is in fact called a convenience sample. Now, clearly, it's not randomly sampled, but I could do a random assignment. So if I had two groups, I could perfectly randomly assign people into one of two groups. And in most cases and in most research, it is really most important to do random assignment rather than random selection. These are more technical terms rather than things that you really need to be aware of when you're doing research. This is something, though, that you probably need to know, and that is that statistics or estimates refer to samples, whereas parameters refer to populations. Whenever we have sampling error, a sampling error is just simply the difference between that which we measure in a sample and that which is in the population. The sample, remember, is meant to estimate the population. As you can see here also, the sampling frame is a list of all the elements in a population, and then the response rate is the percentage of individuals selected be in the sample. Response rate is particularly important whenever you're doing surveys. You send out a survey into a population of, let's say, 1,000. What kind of response rate can you get? And then based upon that response rate, the people who answer those surveys, what is it about them that makes them different from the people who don't answer surveys? So right there you've introduced a certain amount of bias into your study. And as I just started talking about the bias sample, proximal similarity, generalization to people, places, settings, and contexts that are similar to those described in the study. A lot of this you can look over yourself. Again, much of this stuff really this sampling stuff really isn't applicable to your material. However, the first part of this lecture, especially when we were talking about measurement validity and reliability, that's very important. And it also refers to your next assignment that's due at the end of the weekend. Random sampling. I think the thing that you need to remember about the word random and random sampling is that whenever you do a random sample, each element in the population has an equal probability of being selected. So if we have 1,000 marbles in a jar, then each marble has 1/1,000 or 1/1,000ths of a probability of being selected. There are randomizing programs online that you can get. One is on www.randomizer.org and the other is www.random.org. You can see that on the screen as well. you can go through this stratified random sampling, something that's very important when you have very large populations and you've got stratified samples or subpopulations within or under that population, as we do, of course, nationally, many strata. Some of the early tests, the most popular tests, the most important tests, like intelligence tests and MMPI, when they were originally developed, they were just developed on white people, and they didn't cover the entire population of individuals. Now the new Wechslers, the Wechsler 3, the intelligence series, the Wechsler intelligence series, as well as the MMPI, is stratified and does a very good job of covering the various strata of our country. This you can look at yourself. It's fairly self-explanatory what cluster random sampling is. That is, you're breaking it down. You go from states to districts to villages to households. And if you're planning to be a census taker or work in census statistics, this is something that is very important for you to know. So be aware, stay on this page for a while if that's your goal. Systematic sampling involves 3 steps. Again, something that I doubt very seriously you're going to get into, as well as the periodicity involved in systematic sampling. Again, you can review it on the PowerPoint as well as in your book. The book goes into maybe a little more detail. I've tried to include the pertinent points here on the PowerPoint slide. This explains some of the algorithms or algebra involved in systematic sampling. A convenience sampling, of course, is the type of sampling that we are most familiar with. Many of the popular tests today, and I'm not talking about the big major tests, but just some of the what they're called RAIs, rapid assessment instruments, are developed using convenience samples, and that convenience sample is mostly college students. Now, those are, for the most part, still very valid tests, very reliable tests. And again, before you use a test, study its psychometrics. Look at how its validity was established. Look at its reliability. Does it have inter-rater reliability? Does it have test-retest reliability? And does it have internal reliability? Of course, most test makers will state its internal reliability because that's the easiest one to state. But if it doesn't have it, if it doesn't have more than internal reliability, you might want to question the test and see where else the test has been verified. Purposive sampling, snowball sampling, these are all things you can take a look at yourself. Purposive sampling, it's pretty clear. If we're interested only in individuals, for example, with ADHD, then we would go to those individuals. Clearly, that's not a perfectly random sample. It is purposeful. We want to look at only people with ADHD, or if we're doing a drug test on depression, and we're a Merck, and we're spending millions of dollars in a random clinical trial that the FDA has approved, we are clearly going to look for individuals who have clinical depression, but then we are also going to have to impose many controls on that. For example, we would want only individuals within a certain age group, unless, of course, we want to find out what its effects are, and this would be another test, perhaps, on geriatric samples or adolescent samples. Also, we know that certain antidepressants don't necessarily work with people who have had multiple major depressive episodes or chronic depression or extremely severe depression, or individuals who have had to have electroconvulsive therapy for very, very severe depression. There's some other things that we might want to use as exclusive criteria. Lots of suicidal ideation, use of recreational drugs, which will clearly present problems with something we're going to get into next week, and that is threats to internal validity. Random selection and random assignment. Please review this because it is very important that you consider the idea of random assignment. As I've read all of your dissertation or research proposals, some of them don't take random assignment into consideration very seriously. Very important that you do that. 4 simple rules for determining sample size. If less than 100, you have to use the entire population of whatever you're studying. Larger sample sizes make it easier to detect an effect or relationship in the population. And herein is what we're talking about, 2, 3, and 4. Compared to other research studies in area by doing a literature review. So look at a literature review and find out how many they did. And number 4, the most popular. Because in fact, if your dissertation committee is worth its salt in quantitative analysis and quantitative dissertations, they're going to ask you to, when you do your dissertation proposal, to give them a power analysis. And that power analysis assures that you have at least an 80% probability of rejecting your null hypothesis. There are sample size calculators. There are power tables is right here. I'm not going to, this is just up there for example, but you can go on Google right now and look up power analysis tables, and 1,000 of them will come up. Power analysis is based not only on entire or total group number, but also the number of groups, the number of statistical tests you are using, the number of independent and dependent variables you are using, along with some other effects. Do you have any nested groups? Are you doing a time series design? Are you using simple basic ANOVA? Are you using a multivariate analysis of variance? Lots of other factors need to be considered. But again, the tables will do that for you. You find yourself a good table, and it walks you right through it. So that's determining sample size. And again, sample size is something that you want to consider, always want to consider in doing a realistic dissertation proposal if you're doing a quantitative proposal. Qualitative research focuses on in-depth studies of one or few cases, whereas different sampling methods are available, and it's common to mix several different methods. Here you can look at some of the sampling methods used in qualitative studies here.